with this data set, I will be conducting a Way ANOVA test. My research question is, are there differences between students who are trying to lose weight, gain weight, stay the same weight, or aren't doing anything about their weight in terms of the number of days a week they eat fast food as a snack or meal? And I'm going to introduce the variables and how they were asked. Question 103 is our question about fast food, and it reads as, how many days did you eat at least one meal or snack from a fast food restaurant in the past 7 days? And this goes from 0 to 7, and it is coded from 1 to 7, or 1 to 8, and that is why it has the double number there. It's not 1 to 0 days, it's 1 equals 0 days, 2 equals 1 day. It was just double coded, I guess, in a way would be a good way of thinking about that. And then we have, which of the following are you trying to do about your weight? We have lose weight, gain weight, stay the same, and I'm not trying to do anything about my weight. And here again, it's on a code scale, or code. It is coded, rather. 1 being lose, 2 gain, and so on and so on. And now we want to conduct our test. So first we start with analyze, compare means, Way ANOVA, and we want to change over to variable names. It might be a little easier to read. We scroll down. The number of days we want, or we think, is our dependent variable, the number of days that they eat fast food. And if they're trying to do something about their weight is the factor. We click on options. We make sure descriptive and homogeneity of variance test is clicked so that we have that in our output. The homogeneity of variance test is our Levine's test. And then, yes. And so our equal variance assumed, like in our independent t-test, it is rather named different test. And so we have Tukey, and we want to choose that as our equal variance assumed test, and then we want Tamhane as our equal variance not assumed. And our significance level is still going to stay at 0.05. Once that is complete, you can press OK, and it might take a little bit of time to come up. Here's an example of what it had been, and here's our one-way output. And first you get your descriptive statistics, and this looks at the mean number of days that the people who answered these questions ate fast food. And so it shows you that of this sample, of the 10,674, half of those, about a little less than half, were trying to lose weight, and then the others are divvied up in like other 3 categories. And this is a nominal variable, and this is a ratio variable. The reason this is a ratio variable and not an interval variable, because the number of days you ate fast food can actually be 1 or 0, so you have a real 0. And then lose, gain, stay the same, and I'm not trying is nominal because it cannot be put into any sort of order. And so we have our means, and it looks like If you're trying to gain weight, you eat more fast food, or at least more days. There are more days in the week that you eat fast food. There doesn't seem to be a big difference between staying the same and not trying to do anything about the weight, but that's also a very similar answer. So it just might not, if you're trying to stay the same and you're not trying to do, you're going to continue to do what you're doing, or if you're staying the same weight, then you're going to continue to go on the way you were going. To lose, though, is smaller than all of these, and you can see that based on the mean. You can also see the mean of all of these. So of all the people, there is basically a 3-day mean. And then you can look at your standard deviation, your standard error, your confidence interval on each of those, and you can analyze those on how they overlap, and that can also tell you a little bit about significance. And then you can look at your minimum and maximum. And the 8 is not 8 days, that's actually coded as 7 days, or it's coded as an 8, but it means 7 days. And then 1 does not mean that no one in this analysis ate 0. That means that 1 coded as 0 days. Everyone in this analysis had at least one person who had 0 days that they ate fast food. And then we go on to our ANOVA. And here we look at our F test, and that is 67.648. And then we look at our significance. If this was above 0.05, we would stop. We wouldn't look any further. But since it isn't, we can go ahead and look further. And so we go back to our Levene's test, the homogeneity of variance, and this tells us where in our post hoc test to look. The significance is 0.000, which is less than 0.05, and if it's less than, we look at our Tam-Haines. That is equal variance not assumed. If it were more than, we would look at our Tukey, equal variance assumed. So we would scroll down to our post hoc, and we're going to ignore the Tukey, which is in this area. So you're ignoring half of your post hoc, but you want to make sure you have both up, so in case it were one or the other, you would be able to look at it. And then we're going to look at our Tam-Haine. And our Tam-Haine shows us a variety of things. We can look at the variables and how they relate. So our people who are trying to gain weight, we're asking if they are significantly different than the people who are trying to lose weight. And we look at our significance, which is in this column. That's one way to look at it. And they were significantly different, and they were different by this much, and that's our mean difference. So people who were trying to gain weight ate about 0.677 more days, so that than those who were trying to lose weight. And so we can also look at people who are trying to gain weight. Are they different than people who are trying to stay the same? And they are significantly different. And people trying to gain weight are likely, if they're different from the people who are staying the same, they are likely, or they are different from the people who aren't trying to do anything. And they are. We can also look at people trying to stay the same. Are they different from our people who are trying to lose weight? And again, they are 0.000. And they eat this many more days, and it's not a full day, but you can see that it is that mean difference of how much more, or how many more days. And then we look at, I am not trying to do anything about my weight. Is there a difference between staying the same and that? And there is no significant difference. there is actually a very slight difference, but according to this test, there is no significant difference. And if you look through, that is the only one that is not significant. So if I were to say my results, then that would be that the differences are significant between losing weight and gaining, losing and staying the same, losing and I'm not trying, and every other combination except staying the same and I'm not trying to do anything about my weight. We can see the mean differences throughout, but it looks like people who are trying to lose weight will eat less fast food, meaning that they will eat fast food fewer days than those trying to gain weight, stay the same, or those who are not trying to do anything about their weight. But those who are staying the same weight or trying to stay the same weight and not trying to do anything about their weight do not significantly differ between number of days that they eat fast food. Depends on what question you're asking, but this is a generalized answer that you might give. And this is how you conduct a one-way ANOVA.